All right, we're ready to go here. With the target gas law lamp, what you're going to want to do first is you're going to want to fill up this graduated cylinder, overflowing. You want as much water in there as possible. You're going to take a piece of, let's see, what's the cling wrap? Plastic wrap. I can't use saran wrap, it's trademarked. Just use it. All right, what you want to do is not what I just did there. You don't want to get any air bubbles. So you want to have a spare beaker. You don't have to use a giant one like I am. And you want to just you want to finesse this over the top. And that's good. You know, you're going to get 1 or 2 air bubbles. Small ones are better. You're going to hold the whole thing as best you can. You're going to wind up flipping it upside down. So I suggest you actually put your hand upside down as you try and attempt to flip it. That way it's right side up. Get it into the water and set it down on the bottom. Okay. Once it's in the water, you just want to keep the base of the graduated cylinder under the water, and you'll just pull your saran wrap, your cling wrap, out. Set that aside so it can be reused later. You're going to maneuver this over and stick it in the clamp and clamp things down. Ultimately, when you get this moved into place, your water trough has a hole in it. You want that sitting right over the hole. The ultimate goal is not to have any air bubbles in here if you can. So take a minute or two to try and do that. Okay. You're going to also obtain a piece of zinc from me. You want to be sure to mass this using a 100th place balance. And then the next thing you're going to do is you're going to sit around and do some math for a while and figure out exactly how much hydrogen gas this will produce when it's placed in your hydrochloric acid. Once you've got that done, you're going to obtain about 50 to 60 milliliters of 6 molar hydrochloric acid. Now this is not marked and graduated, so that's going to make obtaining 50 to 60 a little difficult. I'm going to estimate. That's about 60 milliliters right there. Notice it's 1 finger of acid. So what you need to do is you need to actually get a way to put the zinc in there. The best way to do this is to actually fold your zinc in half. You don't want to just drop your zinc in, because if you drop it in, it's going to start producing hydrogen gas and you're going to lose it before you get a chance to put a stopper on. So what we're going to do is we're going to fold this twice. We're going to fold it once, put the paper clip on it. Now the paper clip is coated in plastic, so it's not going to react at all in the reaction. So one way of getting the zinc attached to the Erlenmeyer by the magnet is to take the paper clip and just attach it. The way that the lab write-up suggests is to curve the zinc into a half circle. I'm going to say it's a little bit more than half a circle, but the basic reason for half a circle is that the Erlenmeyer is a circular opening. You're going to place it in there. You're going to place the magnet, and you see that fits perfectly. So you get an idea that the zinc is actually being held on. Now, there is another way of doing this. The other way that I like to do this is simply to fold it a couple times. So notice I'm just folding the zinc onto the paper clip. I'm folding one more time over. And then, you know, if I've got some extra hanging off, I might fold it one more time. And this is the tricky part. We have rare earth magnets which are extremely strong. What you want to do is you actually want to get your finger into the flask and get the magnet to hold onto the paper clip. It'll do that through the glass just fine, but you do need to get your finger in there, so make sure there's no acid around the neck. Once that's done, you're going to go ahead and put the stopper on. Anyway, get an idea of the whole thing here. Alright, so this is the nice little piece of plastic. It is going to tell you your grade. Obviously a 10 is full credit and 8 is 8 out of 10, which is a B. So you have to guess, you have to measure exactly where it's supposed to fall. So I'm predicting that my guess that I'm going to generate is going to be about 570 milliliters. So you see here's 400, here's 500, 550, 560, 570. So I'm going to place my 10 out of 10 exactly on 570 because that's where my predictions placed it. So you can see that what we've got here is we've got 9 molar hydrochloric. Whatever concentration hydrochloric I have setting out is the correct stuff. 9 molar is going to work better than 6 molar, which the lab is currently set up to ask for 6 molar. When you add your acid, you want to make sure that your zinc is not actually in your flask, but you're just trying to pour directly into the flask. Now, I'm keeping the acid on a tray because if there's a spill, it's easier to contain the spill. So just make sure that you pour while you're on the tray. Okay. Now, 50 mils. It looks like that. It's about half an inch or so. It's not a lot of acid, and the exact measurement here isn't important. So now you're about ready to start generating gas. Make sure that you've checked with me that I know where your little target is. Again, I've set my target on exactly 570 milliliters because that's how much gas I predicted to have gotten. And then from there, it's just a matter of stopping and pulling the magnet. Notice the reaction is fairly vigorous.
That's why you want the hole underneath that.
The water trough does have a siphon off the side so that the water will wind up going into the sink. Please make sure that the water's going into the sink at some point. And the reaction's just about stopped. That's great because it stopped just under 570 there. It's at about 569. So this is maybe that's probably right about at 570 now. So the last thing I want to talk about here is getting rid of the hydrogen gas, disposing of it. First off, you're going to need a lighter. And you need to make sure that you know how to light it. So you might want to practice that once or twice to make sure that you can get it lit. Because hydrogen gas is going to move pretty quick once you invert your graduated cylinder. But the way this is going to work is pretty simple. All you need to do is release the clamp and lift that up. Now note, guys, hydrogen gas is less dense than regular air. So it's going to stay up here at the top of the column. It's not going to come out until I flip it upside down, and then it's going to move straight up. So what I want to do is I want to be prepared. I want my safety goggles. I want to make sure that nobody is around that doesn't have safety goggles on because this is glass, despite the fact that it's Pyrex. There's a chance that it could crack. Basically what we want to do is just invert it. Using the same underhanded technique that I used before. Voila. You'll get a bang out of it. The test for hydrogen gas. Whoosh. Very nice.